Hello everyone. Today's question, largest divisible subset. Now I will move to pen and paper and explain you the problem statement. So in this problem statement, you are given a set of distinct positive integers. Basically, you have to find the largest subset such that in your subset such that every pair this is I and this is subset J. So Si modulation Sj equals to 0 or Sj modulation Si equals to 0. So if any one of this is equals to 0, then we will consider a part of our subset. Okay, so I if suppose our problem statement is 1 2 3, there is only two subset 1 1 2 and 1 3, and both sides are equal, so you can return any of them as an answer. So 1 3 also correct and 1 2 also correct. I hope now problem statement is clear to you. Now we will move to solution part. So now we have given a distinct positive integer, that is 1 2 3 4, and we will solve this problem using this integer. So first we will take a DP list. Initially this is empty, and now we will take another variable, that is result. Initially our result is also empty, and we will take another variable, that is size. Initially our size is 0. Okay, and now we will traverse from our first element, so that is 1. So here I will solve this problem using two pointer, and in first for loop I will take two for loop. One for loop is traverse from index 0 to alien nums, and another is follow this pointer. The first pointer is I and another pointer is follow this I pointer. Another pointer J is in range of I. Okay, so first our value is 1, and our current size is 1, current result is nums I, so that is 1. Okay, and this time we will not start our J pointer because our I is pointing to 0th index, so J is always pointing up to I minus 1. So if we now our I minus 1 will minus 1, so we will not start our J pointer. So we simply add our current result. Current result is 1, and we check our current size is greater than size. Yes, current size is greater than size, so we will update the size, and our current result is our current result. We will add our current result in result, that is 1, and we will add our current result in DP. Okay, so now our I is pointing to this place, and again our current size is whenever we increment our I pointer, we update our current size as 1, and now our current result is the I index value, so that is 2, and now we will start our J pointer. Now J is point to this place, and now we check one more condition, that is our 2 modulation J is point 1 is equals to 0. Yes, this is equals to 0. And what we will check? We will check dpj. J means 0th index. dp0, length of dp0, length of len dpj, this is 0 plus 1, cause this is matched, so we will add plus 1. Getter equals to current size. Yes, this is getter equals to current size is 1, and this is 1 plus 1 2. Yes, so we update our current size len dpj plus 1, that is 2, and our current result is dpj plus our current value, so that is 2 plus dpj, that is 1, and we will add it. So as there is no more scope to visit next element, because our I is pointing to 1 and j is pointing to 1. So now we add this in our dp, that is 1 2. Okay, and now what I will do, I will check our current size. Our current size is greater than size. Yes, our current size is greater than size, so we update our size to, and result also, result is 1 2. So our result is current result, that is 1 2. Okay, now our I is point to this, and again, whenever I always said, whenever we change our I pointer, we always update our current size, so that is 1, and current result, that is 3. Okay, and now again we will start our j pointer from 0. So now we will compare 3 is divisible by 1. 3 divisible by 1 equals to 0. Yes, 3 divisible by 1 equals to 0. Then we will check length of dpj. So dpj is length of dpj, so this is 0 and this is 1. So length of dpj is 1, because there is only one element, plus 1, because this 3 is divisible by 1, plus 1 means 2, is greater than current size. Current size is 1. Yes, this is greater than, so we will update our current size to 2, and current result, that is dpj plus current value 3, that is 1 and 3, 1 plus 3, 1 3. So now I will move the j pointer, because now our I is 2, so we can move our j pointer up to 1. So now our j is 1. Okay, so now our j is pointing to 2. So we check 3 divisible by 2. We check 3 divisible by 2. No, 3 divisible by 2. 3 divisible by 2 not equals to 0. So we will not check another condition. So we simply add our current result in dp, that is 1 3, and check our current size is greater than our size and our current result. So our current size is not greater than our size, so we will not update our result. Okay, so now we will move our I pointer. Now our I is pointing to index 3, and whenever we move our I pointer, we always update our current size and current result. Now our current size is 1 and current result is 4. Again we will check our j pointer from starting index. Now our j is point to 0th index, that is the value is 1, and our current result value is 4. 4 divisible by 1. 4 divisible by 1 equals to 0. Yes, 4 divisible by So now again we will check length of dp j, so that is 0 plus 1 plus 1, that is 2. 2 getter equals to current size, yes, 2 getter equals to current size, so we will update our current size as 2, and now we will update our current result, so that is 1 means dp j plus our current value, that is 4. Now what I will do, I will move our j pointer. Now j is pointing to 2, so 4 divisible by 2 equals to 0, yes, 4 divisible by 2 equals to 0. Now j's value is 1, so dp 1, so length of dp 1 that is 2, 1 and 2, so dpj point to this value, so length of this value is 2, 2 plus 1, that is 3, so 3 is greater than current size, yes, 3 is greater than, so we will update our current size, so that now our current size is 3, and we will update our current result also. So current result is our current value that is 4 plus dpj value, so that is 1, 2 and 4. Okay, so now again I will move our j pointer. So now our j is point to index 2. So now I will check 4 divisible by 3 equals to 0. No, this is not. So simply we will add our current result in dp. So our current result is 1, 2 and 4. Add this inside our dp, and now what I will do, I'll check our current size is greater than size, yes, current size is greater than size, so we will update our size equals to current size, so that is 3. We will update our result equals to current result, 1, 2 and 4. So now we will move our j pointer, I pointer, that is in 4 index 4, and our j again will start from 0. Again we will check this and this and this and this and this. Okay, so first I will check 1 divisible by 8, yes, 1 divisible by 8, so 8 divisible by 1 equals to 0, yes. So our current size, whenever we change our I pointer, we set our current size and current result. So our current size is 1 and current result is 8. And now our LE and DPJ plus 1, LE and DPJ, j is pointing to now 0, now pointing to 0. Okay, so now j is pointing to 0. So we compare our j dpj, LE and dpj, that is 1 plus 1 is greater equals to current size, yes, is greater equals to current size. So I will update our current size equals to 2, and current result equals to dpj, that is 1 plus our current value. Okay, now we will move our j pointer. Now j is pointing to 2, so again we will check our I divisible by 2 equals to 0, yes. So now we check, now our dp j value is 1, so now length of dpj means length of this value is 2 plus 1, that is 3 greater than our current size, yes, 3 is greater than our current size. So I will update this current size as 3, and we will update our current result, this plus our current value. 1 2 plus our current value, that is 8. So again I will move to index 2 and check 8 modulation by 3 equals to 0. So no, this is not. We'll move our J pointer to this place. 8 modulation 4 equals to 0. Yes. So and we will check our J value is 3. This time J value is 3. So length of dpj means this length of this is 3 plus 1, that is 3. This value, that is length of j 1 to 4, that is 3. Length is 3. 3 plus 1, that is 4. 4 is greater than current size 3. Yes, 4 is greater than. So now what I will do, I will just update our current size, so that is 4, and our current result, this value plus our current value. One, 2, 4 plus our current value is 8. So 1 2 4 8. So we covered all this element. So now what I will do, I just simply add our current result in our DP. So I'm sort of space here. So we will append 1 2 4 8 inside this DP and check our size is 3. So our current size greater than our size. Yes. So I will update our size, that is 4, and update our result also. So our result is 1 2 4 8, and this is our desired answer. Okay, so I hope problem statement and solution is clear to you. If you are not understand, please watch my implementation part. After watching implementation, I hope it will be definitely clear to you. So okay, now I will move to implementation part. For implementation, first I will sort our nums array. So after that I will take a variable, that is size. Initially our size is 0, and now I take two lists, that is res and dp, and now I will traverse our nums. Here I is defined index and num is the ith index value. And now I will always, when I will increment our I pointer, always reset our current size, so that is 1. And now inside this current result I will store first our ith index value, so that is num. Now I will take another for loop that is pointing to j, and I will run it from 0th index to index I, range I. Okay, and now I check if our num modulation by nums j equals to 0, then I will check len j plus 1 greater than our current size. So if it is, then I will update our current size equals to len dpj plus 1. And now what I will do, I will update our current result. So I will add the current value, that is ith index value plus dpj. And now after completing the jth iteration, we add the current result in our dp, and we check our current result is greater than our current size is greater than our size. So if it is greater than, then we will update the size and update the result list also. At the end, I will simply return a result as our answer. Now I will check our code is working or not. Yes, and submit it. Yeah, got accepted. If you will like this video, please give me a thumbs up, and if you have any doubts, leave a comment below. If you are new to this channel, please consider subscribe and don't forget to hit the bell icon.